Units and measurements. Introduction. Measurement of any physical quantity involves comparison with a certain basic arbitrary chosen internationally accepted reference standard called unit. The result of a measurement of a physical quantity is expressed by a number or a numerical measure accompanied by a unit. Although the number of a physical quantity appears to be a very large, we need only a limited number of units for expressing all the physical quantities, since they are interrelated with one another. The units of the fundamental of or base quantities are called fundamental or base units. The units of all other physical quantities can be expressed as combinations of the basic units. Such units obtained for the derived quantities are called derived units. A complete set of these units, both the base units or derived units, is known as the system of units. The international system of units. In earlier times, scientists of different countries were using different system of units for measurements. Three such systems, the CGS, the FPS or British system, and the MKS system, were in use extensively till recently. The base units for length, mass and time in these systems were as follows. In CGS system, they were centimeter, gram and second respectively. In FPS system, they are foot, pound and second respectively. In MKS system, they were meter, kilogram and second respectively. The system of unit which is at present internationally accepted for measurement is the system international units, French for international system of units, abbreviated as SI. The SI, with a standard scheme of symbols, units and abbreviation, developed by the Bureau of International Des Poids et Measures, the International Bureau of Weights and Measures (BIPM) in 1971, were recently revised by the Central Conference on Weights and Measure in November 2018. The scheme is now the scheme is now international in scientific, technical, industrial and commercial work. Because SI units used decimal system, conversion within the system are quite simple and convenient. We shall follow the SI units in this book. In SI, there are 7 base units are given in table 1.1. Besides the 7 base units, there are 2 more units that are defined for a plane angle d theta as the ratio of the length of arc ds to the radius of r and b. Solid angle d omega as the ratio of the intercepted area dA of the spherical surface. Describe about the apex O as the center to the square of its radius r is shown in figure 1.1 and b respectively. The units for the plane angle is radian with the symbol rad, and the units for the solid angle is stadian with the symbol SR. Both these are dimensionless quantities. Note that when mole is used, the elementary quantities must be specified. These quantities may be atoms, molecules, ions, electrons, other particles or specified groups of such particles. We employ units for some physical quantities that can be derived from the 7 base units, appendix A6. Some derived units in terms of the SI units are given in appendix 6.1. Some SI derived units are given a special name, appendix 6.2, and some derived SI units make use of these units with special names and the 7 base units. These are given in appendix 6.2 and A6.3 for your ready reference. Other units retained for general use are in are given in table 1.2. Some common SI prefixes and symbols are multiplied and sub multiplies are given in appendix A2. General guidelines for using symbols for physical given in appendix A7, and those for SI units and some other units are given in appendix A8 for your guidance or ready reference. A3, as discussed above, every measurement involves errors. Thus, the result of the measurement should be reported in a way that indicates the precision of measurement. Normally, the reported results of measurements is a given number that includes all digits in number that are known reliably plus the first digit that is uncertain. The reliable digit plus is the first uncertain digit are known as significant digits or significant figures. If we say the period of oscillation of a sample pendulum is 1.62 second, the digit 1 and 6 are reliable and certain, while the digit 2 is uncertain. Thus, the measured value has three significant figures. The length of an object reported after measurement to be 287.5 cm has four significant figures. The digit 287 are certain while the digit is 5 uncertain. Clearly, reporting the result of measurement that includes more digits than the significant digits is